support count. Those item sets that were infrequent, they were because their subsets were also infrequent. So we pruned out the entire portion of the lattice, which yielded in infrequent item sets. That was the a priori principle. And this was a priori algorithm. So this a priori algorithm is not complete. This is just the first part of the algorithm, which is how we do support based pruning to find out frequent item sets. Remember, our task was to find association rules, strong association rules, x goes to y. In this step, we have only found out frequent item sets. So in these steps, we have only found out frequent item sets. There will be another algorithm which is basically another sub algorithm. This is one algorithm for frequent item sets. Then there will be another algorithm which is the part 2 of a priori algorithm, which will be the rule generation algorithm. So I am still continuing with the frequent item sets and how we can use some heuristics to prune further, so we can eliminate further comparisons and eliminate more computationally intensive tasks. So if you remember, in the last lecture we talked about that we first generate all F1 item sets, that is all item sets of size 1 which cross the min sub threshold. Then we generated candidates for next level, which was F2. So F2 we got from, so basically, sorry, candidates for F2 we got from a priori gen, previous step frequent, because only frequent will move to the next step. We are assuming that those are who are infrequent at this step will not be able to contribute to the further steps. So the frequent item sets of previous step will become will form the candidate item sets for the next level, and at each level we formed a candidate, and for that candidate we computed the support count. We continued this till all the entire F1 and candidate generation was complete, and we computed support count for each candidate. For all those candidates whose support count exceeded the min sub, we put them in the F2 set. So these are all, so there will be a lot of candidates generated, but only those who qualify this min support criteria will move to F2. Then we will repeat this till we are not able to find any more item sets, frequent item sets. So at one level your tree will stop, and then all the frequent item sets will be combined in one set. That was the a priori algorithm. And we found out, for using one example, in that particular example we could reduce the number of candidates by 70%. Obviously it will be different for different examples. So if you have a question you can ask me, otherwise I can move forward. This is what we had done in the last lecture. If you have studied and if you have questions you can ask me. Okay, so the other thing that you will note about a priori algorithm, that it does the level wise traversal. The entire lattice is traversed starting from root, then level 1 for frequent item sets 1, then you go to level 2 where one frequent item set are combined to form 2, then level 3, level 4. So you are traversing and checking the candidates at each level. So you start at the root and you go to the maximum level to find the frequent item sets. So at each iteration, you are able to find new candidates and determine frequent sets from the previous iteration and test them against minimum support. The total iteration will be k max. So this will be k max and this will be 1. So you have total iteration which is k max, that is a maximum length to which you can form the item set, plus 1 because you have already covered one over here, one level over here. So these are the total iteration, and k max is the maximum size or the last tree level. So now what are the properties of an effective candidate generation algorithm? An effective candidate generation algorithm should avoid unnecessary candidates. The candidates that are unnecessary or infrequent should be avoided. So a priori algorithm is doing that. It should be complete. That is, you should not leave out any frequent sets. So your fk should be a subset of ck. It should be a subset of candidate set. So obviously all the candidate sets can become frequent item sets also. Plus you should ensure that there are no duplicates. So this is a property of a good candidate generation algorithm or effective candidate generation. So typically this question is asked in Viva also. Now, various candidate generation procedures, if you are talking about brute force and you have k item sets which are the candidates, then and you have d total items in the inventory, then DCK is how you are going to pick up the candidates. It becomes a computationally expensive task because for all item sets, what you are going to do, there will be order k time to find each candidate multiplied by DCK possibilities. So, and k will be equals to 1 to d. So, this is an exponential task to find the candidate. So, this is how, so basically we are talking about this portion, how to generate candidates, how this a priori gen will work. So a priori gen, if you apply if you find candidates one by one using brute force, it will be exponential. So there are some methods where you can generate candidates by pruning out some irrelevant ones. So this is fk minus 1 cross f1. So you can expect a numerical based question on this. There are a lot of questions that are given as assignments in the book. You can attempt those also. So to generate candidate apart from brute force, another method is using fk minus 1 cross f1. That means suppose you have to generate frequent item sets of size 4. So that can be generated using by combining f3 cross f1. That is, you already have a 3 frequent item set, combine it with 1 frequent item set. Obviously they should be disjoint. So if you have f5, then you will combine set of 4 with set of 1. So to generate uh, candidates, this is one of the methods. Let's see how it works. Let's take an example. So extend frequent item set at the previous level with other frequent items. So if you here they are generating F3. Now so F3 can be done using F2 cross F1. So F2 you already have. You have beer and diapers, you have bread and diapers, you have bread and milk, and you have diapers and milk. So this is F2 and this is F1. So how you are going to combine? So beer and diapers you cannot combine with beer because beer is already present. They have to be disjoint. Beer and diapers you can combine with bread. So this is one candidate. Beer and diapers you cannot combine with diapers. Beer and diapers you can combine with milk. So this is another candidate. Then bread and diapers and beer is already covered, so you need not write it again. Bread and diapers and bread cannot be combined. Bread and diapers could not be combined. But bread, diapers and milk can be combined. So you have written it over here. Then you talk about bread and milk. So bread, milk and beer I think is not covered. So you write it here. Then bread, milk and bread cannot be combined. Bread, milk and diapers is already done, and bread, milk and milk cannot be combined. Similarly, diapers, milk and beer is covered. Diapers, milk and bread. Diapers, milk and bread is also covered. Diapers, milk and diapers you cannot combine, and diapers, milk and milk you cannot combine. So we have effectively generated candidates using this way. Is there a question now? Okay. So you have generated candidates and then you found out that, okay, for example, beer was infrequent at previous levels, if you remember. Because beer was infrequent, so only one item set will move to the next level. So only bread, diapers and milk will move to the less level. Others have been pruned out because beer and diapers were beer and diapers combined. Beer was infrequent, and the time that it took was, you have analyzed the entire fk minus 1, so mod of fk minus 1, and with for each fk minus 1 you have traversed this f1 every time. So it is mod of fk minus 1 cross f1 for one item set, and for k item sets it is sigma k into fk minus 1 cross f1, which is definitely, obviously this is a polynomial time as compared to exponential time, so this complexity is reduced. Any questions? Okay. So the other thing, how you are going to combine the things to remember is, and what is interesting is that this is complete because you are comparing k minus 1 to 1 item set. All the k minus 1 are compared and combined with one item set. It can generate duplicates. So to avoid generation of duplicates, you store it in lexicographical order and then extend lexicographically only. So store it in lexicographical order and then generate it and then extend it lexicographically. Then you will not be able to, then you will not be generating duplicates. But this is complete. You may generate unnecessary candidates like this, but we know that beer and milk was infrequent. Beer milk was infrequent, that's why it did not make it up to F2. It did not lead to F2 because it was pruned out at the previous level only. So all those item sets that contain beer and milk will be pruned out and you will be left with only one item set. So again you have applied the a priori principle that if a subset is infrequent, then its superset will also be infrequent, so you can prune it out. I hope this is clear because do expect such kind of questions in the exam. Okay. So another heuristics to prune out is that every k item set that escapes pruning, and every item in k item set must be in at least k minus 1 item sets. So to eliminate items, you have to say that there is a k item set and there are item sets that have escaped pruning at the previous level. So for if you have to prune it out at the next level also, then check whether at fk minus 1 level, is it in k minus 1, is it occurring k minus 1 number of times, is it occurring in k minus 1 item sets? If yes, then it goes forward. If not, then it is infrequent. So in this situation, if you see that in case of beer, diaper and milk, milk was frequent because in F2 it was appearing in at least two positions. It was appearing in two positions. Diapers was occurring in three positions, and beer was occurring in one position, and our heuristics was that it should appear in at least k minus 1 item set. So it should have appeared in two, but it is appearing only in one. So the beer portion we can eliminate. So that's why we need not merge beer and diapers and milk, because, oh sorry, that's why we can eliminate those that have beer. The other thing is that beer, diaper and milk need not be merged because they are lexicographically different. So the heuristic to eliminate says that if you want to eliminate an item, just check whether it is in k minus 1 item sets. If it is less than k minus 1 item sets, then you can prune it out because it is infrequent. So now tell me if there is a question.
Can you please explain it once again?
Yes. So what we are doing is that we are telling you, we are discussing how to remove unnecessary candidates. So one heuristic is that heuristic means it is something that has been noticed before. It is a trend. It is some previous knowledge that we are using. So it is saying that if there is a k item set and it is escaping pruning, you have to check whether every item in this k item set, so this is a three item set, every item in this three item set is there in at least k minus 1 item sets at the previous level. So अगर मैं ब्रेड मिल्क और बियर की बात कर रही हूँ, तो उसमें जो ब्रेड है वो एटलीस्ट टू में आना चाहिए, मिल्क एटलीस्ट टू में आना चाहिए एंड बियर एटलीस्ट टू में आना चाहिए. अब ब्रेड तो आपके टू में आ रहा है, मिल्क भी टू में आ रहा है, बट बियर टू में नहीं आ रहा. तो इसका मतलब बिकॉज बियर टू में नहीं आ रहा तो ये वाला सेट फ्रीक्वेंट नहीं रहेगा, तो इसलिए हम इसको एलिमिनेट कर सकते हैं. So this is what they are saying. Use the heuristic, consider beer, diaper and milk. So if every item is in at least two item sets, then it can come here, otherwise it cannot come here. So diapers is in 3, milk is in 2, but beer is only in 1, so it can be eliminated. Okay, if you see, diapers is in 1, 2, 3, milk is in 2, so it is satisfying the heuristic. But the third element beer, we are saying every item in this has to be there in k minus 1 in the previous level. So it is not in k minus 1, it is k minus 1. यहाँ पे 3 है तो k minus 1 क्या हुआ, 2 में होना चाहिए, 2 में होना चाहिए था एटलीस्ट, बट ये 2 में नहीं है, सिर्फ 1 में है, तो उसको आप एलिमिनेट कर सकते हो. Is that okay?
Yes, ma'am.
Great. So this is one way, fk minus 1 cross f1 to generate candidates. Another way is to generate candidates using fk minus 1 cross fk minus 1. मतलब f3 एंड f3 को कंबाइन करो, सॉरी इधर f2 दिया हुआ है ना, f2 एंड f2 को कंबाइन करो f3 जनरेट करने के लिए. तो इसका तरीका ये है कि जहां पे भी if you are creating k and you are combining k minus 1, so you match k-2, जिनके जो k-2 आप हम ये हमारी बेसिक एग्जाम्पशन रहेगी कि हम लेक्सिकोग्राफिकली अरेंज कर रहे हैं. तो बियर इज लेक्सिकोग्राफिकली स्मॉलर देन ब्रेड and then diapers is the greatest. Here also you are generating lexicographically. So the entire ordering is lexicographic. We are saying that if we have to combine, if we have to find F3 candidates, then you are combining F2 cross F2. But how we are going to do that? You will match first k minus 2 items. In this case, k minus 2 is what? 3 minus 2 is equal to 1. So you will match first one items, and if so in this case beer is not occurring anywhere else, so this will not be occurring. Bread is occurring, first item is bread, and you have diapers and you have milk. So basically bread is matching, and so you are saying that you have bread. So you combine all those where first k minus 2 are matching. So bread and diapers and bread and milk में match मिल गया आपको. So bread and diapers और bread and milk में match मिल गया, तो bread तो जा ही रहा है और उसके बाकी के दो भी जा रहे हैं. उसके अलावा आपको किसी और में match नहीं मिला है. Is this clear? So if first k minus 2 are identical, then you can merge. Otherwise, don't merge. That is another way to generate candidates. Is this clear or should I explain it once again? Even if you don't ask, I am explaining it once again. You are generating k equals to 3, right? So you want to generate f3. So to generate f3, you will combine fk minus 1, which is f2. The way to combine is this, that match first k minus 2 items. In this case, k is 3, so for match first item and combine those candidates where there is a match at k minus 2 items. So first item, beer किसी से भी match नहीं कर रहा apart from itself. ब्रेड एंड डाइपर्स एंड ब्रेड एंड मिल्क मैच कर रहे हैं, तो आप उनको कंबाइन कर सकते हो. फिर डाइपर्स किसी से भी मैच नहीं कर रहा, तो जहां पे भी फर्स्ट के माइनस 2 आइटम सेम है उनको आप मर्ज कर सकते हो. सो दिस इज अनदर कैंडिडेट जनरेशन प्रोसीजर. So there, for example, if you have candidates A, B, C, A, B, D, A, B, E, and so on. So this is 3 item set. You have to generate 4, F4. So K is 4. So you have to match K equals to 2 now. Sorry, K equals to 4 minus 2. K minus 2 करना था ना, तो first 2 match करो. First 2 match करोगे तो A, B वाले combine कर दोगे. तो किस में मैच है फर्स्ट टू में? ए बी वालों में. सो यू विल कंबाइन ए बी सी डी एंड ए बी सी ई एंड ए बी डी ई. सो ए बी सी डी, ए बी सी ई एंड ए बी डी ई. You cannot combine others because first two are not matching. So A, B, C, D is a candidate. That's how it works. Okay. This is complete because each k minus 1 is checked with other k minus 1. Because you are in lexicographic order, you will be preventing the duplicates. But because you are merging k minus 1 frequent item sets, you might need to do additional pruning. So for example, यहाँ पे A B C A B D है, तो इसके आपके पास A B C D A B C E A B D E and B C D E आ गए. अब इसमें से अगर आप चेक करो तो I think I should have written ओके. ए बी डी आपको एलिमिनेट करना पड़ेगा क्योंकि ए डी ई प्रीवियस में फ्रीक्वेंट नहीं है. यहाँ पे कहीं पे भी ए डी ई, तो क्या हमने एप्रियोरी प्रिंसिपल क्या बोलता है कि अगर कोई सबसेट इनफ्रीक्वेंट है तो उसका सुपरसेट भी इनफ्रीक्वेंट होगा। आपने कैंडिडेट्स तो जनरेट कर लिए एफ के माइनस वन क्रॉस एफ के माइनस वन से। अब आपने इनको चेक करना शुरू किया कि कोई एडिशनल प्रूनिंग की जरूरत है। तो एडिशनल प्रूनिंग क्या है, ए बी डी को चेक करो। ए बी डी तो आ रहा है, बट ए डी ई नहीं आ रहा है। तो ए डी इज नॉट frequent in it is not in F3, so you can remove this. A B C E में आपका ए सी ई और बी सी ई नहीं आ रहा है तो इसको भी रिमूव कर दो। बी सी डी ई में बी सी ई ऊपर कहीं नहीं आ रहा है तो इसको भी रिमूव कर दो। तो आपके पास एक ही बचा विच वॉज ए बी सी डी। So you have removed other candidates. Oops, sorry. You have removed other candidates also, and you have pruned out additional candidates, and only one is left. अब ये जो लेफ्ट है ये कैंडिडेट ही है, फिर इसका सपोर्ट काउंट चेक करोगे। सपोर्ट अगर वेरीफाई हो जाएगी तो ये फ्रीक्वेंट जाएगा, नहीं तो यहीं पे रुक जाओगे। तो अभी हम सिर्फ कैंडिडेट जनरेशन की बात कर रहे हैं, ब्रूट फोर्स की बात करी, और ब्रूट फोर्स के बाद एफ के माइनस वन क्रॉस एफ वन की बात करी और एफ के माइनस वन क्रॉस एफ के माइनस वन की बात करी। आफ्टर generating the candidates, you will be determining the finding out the support count. So basically you have found the candidates, so the rest of the sets you will be ignoring. So firstly you have to determine the frequency of every candidate that survives pruning, and you have to compare it with each transaction. Naturally it's a computationally expensive task still. Even though you have eliminated a lot of sets, it's still a computationally expensive task. So इसलिए क्या करो, each item set को transaction में number दे दो and update support counts for respective candidates. So let's say that आपकी transaction में 1 2 3 5 6 items थे, and so there are how many ways, how many item set possible? If you are talking about frequent 3, so there are 10 item sets possible. So you will increment support counts of only those which are under consideration and ignore others. So if that means that you had 1 2 3 5 6, then in that scenario let's assume that I your item sets were only that beginning with 1 2 and 3. So the candidates were that began with 1, that began with 2, and that began with 3. Let's assume that those that began with 5 and 6 were not frequent, so you will ignore that. Now to compute the support count, you will build a tree for the transaction 1 2 3 5 6. So if it starts with a 1, the other three elements can belong to 2 3 5 and 6. So now after starting with the 1, if it starts with a 2, the other candidate could be 3 5 6, because we have already covered 2. So if it starts with 3, other candidate possible could be only from 5 and 6, and other candidate that is possible at the level of 5 can be only 6. Once 1 2 is done, so your possible candidates are 1 2 3, 1 2 5, and 1 2 6. Similarly 1 3 5, 1 3 6, and 1 5 6, and the same goes for 2 and 3. So you have eliminated 5 and 6 because they were not your candidates. Now you have built a tree for the candidates which started from 1 2 3. Now you will, whatever candidates will come in this transaction, you will go to that path and increment the relevant count. So in this situation you will go to 1 2 3 were there, so its का count भी increment हो जाएगा. उसके बाद क्या कहते हैं, बिकॉज फ्रीक्वेंट सबसेट्स हैं 1 to 5 का भी काउंट इंक्रीमेंट हो जाएगा. जो भी फ्रीक्वेंट सबसेट्स हैं वो आपको, जितने भी फ्रीक्वेंट सबसेट्स हैं 3 आइटम्स के, वो आपको ऐसे मिल जाएंगे. इज दिस क्लियर? So instead of comparing each candidate with every item in the transaction, हमने transaction को split कर लिया, हमने candidates को number कर लिया, और transaction को split कर लिया उस जितने भी पॉसिबल कैंडिडेट्स थे उसके हिसाब से हमने एक ट्री फॉर्म कर लिया एंड वी फाउंड आउट. सो बेसिकली देयर वाज नो रेपिटेशन, यू ट्रैवर्स्ड इट ओनली वन बाय वन. सवाल ही नहीं है तुम लोगों के. Okay. So there are three item sets that begin with only 1, 2 or 3. All sets starting with 1 have been considered here and the left side. Starting with 2 are there in the middle of the tree, and starting with 3 there is only one option. So you have built a tree and you need not traverse and check with one again and again. Simply number the item sets and build a tree and cover going from left to right. So there will be no multiple iterations. So another way to count the support is using hash. Till now you have been comparing item sets with each transaction. Now instead of comparing, hash the item sets to a bucket. So whatever item sets you have found, उनको उनके लिए उनको नंबर कर दो और उनकी एक बकेट बना दो. Once that item set comes in the transaction, उसका hash function compute करो और रिस्पेक्टिव बकेट में जाके काउंट अपडेट कर दो. आई थिंक दिस इज हाउ वी हैव बीन यूजिंग हैशिंग in data structures also. So what you are doing is, for each item set that you are talking about, create a respective bucket, hash bucket. उसके लिए एक hash function डिजाइन कर लो. And now scan the transaction, and whatever item sets come in that transaction, create a hash for it and map it to the bucket and increment the support count there. So here is you can use a hash function. It could look something like this. So for example, if you have items 1, 4 and 7, then they will go to the same bucket. So item set starting with 1 are hashed to the left, with 2 are hashed to the middle, and with 3 are hashed to the right. This is a transaction tree, and this is how, so you have numbered it and found the number of items. Now the transaction came. When the transaction came, it was starting with 1. So now when it was starting with 1, you went to the one part of the tree, and when you went to the one part of the tree, you came up with 2. Then you came up with 3, 5 and 6. So one part came here, then 2 would help you map it over here, and 3 will help you map it over here. Is there any question? Because I am done with the topic. If there is a question, you can ask. Any questions? Next week, I will be doing rule generation. On Wednesday and Thursday, I will be finishing off with rule generation. If you have questions, you can ask, otherwise, you can leave.